Climate change attracts global attention. Low-carbon economy is on the rise. Biogeochemistry deals with the effects of living organisms on the concentrations of chemical elements in the different reservoirs of Earth: lithosphere, hydrosphere, atmosphere, and biosphere, and changes in the cycling of chemical elements among reservoirs, thus could substantially influence the climate. Among the reservoirs, the ocean acts as a buffer of global climate change. It accounts for about 70% of the Earth's surface and acts as an important carbon pool. So, how does the ocean absorb carbon dioxide? Several major mechanisms are proposed for ocean carbon storage, called carbon sequestration, that could have large impacts on global climate change. The solubility pump, which is driven by differences in carbon dioxide partial pressure, is a physicochemical process that transports dissolved inorganic carbon from the ocean's surface to its interior. It leads to ocean acidification, which may have negative or unpredictable effects on marine organisms. Carbon can be also biologically fixed in the form of calcium carbonate, used as a protective coating for many planktonic species, such as coccolithophores and foraminifera, as well as larger marine organisms, such as mollusk shells. This process also releases carbon dioxide and is thus called the carbonate counterpump. Another known biological mechanism for carbon sequestration is the soft tissue or organic carbon pump, based on sinking processes. The amount of particulate organic carbon sinking to deep waters accounts for about 1% of what is produced in the ocean surface. Then, where has the rest of the carbon gone? The majority of organic carbon is transformed to carbon dioxide by respiration, and eventually returns to the atmosphere. There is a vast reservoir of dissolved organic carbon in the ocean, which accounts for 95% of total organic carbon, among which 95% is bound up as refractory dissolved organic carbon, whose dormant time is about 5,000 years. This dissolved organic carbon reservoir in the ocean is comparable in magnitude to the total inventory of atmospheric carbon dioxide and may play a role in climate change. However, how is the refractory dissolved organic carbon formed? It has been a puzzle to solve. There are very numerous, almost invisible microbes in the ocean. In general terms, heterotrophic microbes are considered as decomposers which consume organic carbon. However, decomposition also produces dissolved organic carbon unavailable to microbes, contributing to carbon sequestration in the ocean. Similarly, viruses are not only pathopoesia. Viral lysis releases refractory organic carbon into the water. Such transformation processes, as well as other microbial processes that transform organic carbon from labile states to refractory states, constitute carbon sequestration in the ocean and are called the microbial carbon pump. The cycling of carbon, especially when it is coupled with other elemental cycles, is one of the major research topics that is not yet fully understood. A multidisciplinary effort is required to address challenges in global carbon process research. By bringing together marine biogeochemists who presently work in a large number of international programs, the GRC would be a cradle for novel ideas and approaches to be developed to understand the role of the ocean in global climate change.